Hello guys, welcome to Science Paper 2 revision. This is the paper that was written in 2017, the 1st of August, Examinations Council of Zambia, Examinations for General Certificate of Education Ordinary Level. So this paper I did it again, but it appears that it only recorded up to question 7, then the other party remained unrecorded, but it managed to record just the audio version of it. So guys, I apologize for the inconvenience caused, but here I am redoing it again. Alright, so let's go straight into the revision. Alright, so this is the section A, 20 marks. Answer all the questions on the answer grid provided. A1 says some cold water is poured into a conical flask and a bung inserted. The diagram shows the flask after being left in open air for some time. Alright, so there's a conical flask with some cold water in it and then a bung inserted, and this is left in an open air. Then when the question says what is occurring in the flask, first we look in the flask, we are seeing air and water vapor. So when you look at air and water vapor, what must come in your brain is that if there's water vapor, there's some evaporation going on. Alright, so if there's some evaporation going on, definitely you consider some condensation also to go on, because this conical flask is enclosed. Alright, so when they say what is occurring in the flask, our answer should be, they're saying A, boiling, and D, condensation. No, there's no heating here. Then here, evaporation and condensation. Right, correct, there's evaporation and condensation. So the answer is actually B. Alright, for A2, let's push it up here. So A2 is saying which of the following is not true about evaporation? Which of the following is not true about evaporation? So A, it involves a physical change of state. This is true. B, the particles gain kinetic energy. Yeah, in evaporation, particles gain kinetic energy. Then you see it is a non-reversible change. Not true. So the answer is C. Then A3 says identify a mixture of substances that can be identify a mixture of substances that can be we identify a mixture of substances that can be separated using the apparatus below. So this is a separating funnel. Here they're saying a mixture of A, paraffin and water, B, common salt and iodine solution, then here C, sugar solution and alcohol, then in D, alcohol, and D, water. So the answer is actually A. So let's go to A4. Says the nuclide of an aluminium ion is written as 2713, then Al3 plus. Then they're saying state the numbers of neutrons and electrons in the nuclide of the ion. So yeah, so this one, the answer is C. Then A5 says ethane has the structure shown below. So ethane has the structure shown below. Alright, so let me just explain here before I go anywhere, because my cautious won't allow me to just go without answering this question. So here is the issue. So okay, I've selected black. Alright, so now what it is here, you have been told that you have aluminium, which is in A, L, then they've said 3 plus, then here they've said 13, then here they've said 27. Alright, then they're asking you to say state the numbers of neutrons and electrons in the nuclide of the ion. So this is an ion. So they want you to state the number of one neutrons, then two, they want the number of electrons. So what you should know initially is that in a neutral atom, the number of electrons is equal to number of protons. So this number here represents proton number or atomic number, and in a neutral atom it represents actually also number of electrons. Then this number here represents atomic mass or relative atomic mass, and then relative atomic mass, this one represented by A. Relative atomic mass is the sum of the number of protons and the number of neutrons. So if I have like a number of neutrons plus number of protons, then I add them, then I should get relative mass number, which is the value here. So here when they want us to know the number of electrons and I mean neutrons and the number of electrons. So what we are going to do here is to replace. So we know proton number is this, so say n is plus proton is 13, all right, so is equal to, then a relative molecular mass or atomic mass is 27, all right. So this one now becomes a mathematical equation where you are going to say this number crosses the equal sign, so n is equal to 27 minus 13, all right. So 27 minus 13 will give you, now the answer is going to be 14. So meaning here the answer is 14. Then here the number of electrons is equal to the number of protons. Now this is an ion, so if it is plus 3 or 3 plus, it means it has lost 3 electrons. So you remove 3 electrons, then you remain with 10. So the number of electrons is 10. So neutrons 14, electrons 10. This is why we found this one. Neutrons 14, electrons 10. Yeah, so now I'm happy I've answered it accordingly. So F5 says ethane has the structure shown below. So this is the structure of ethane. Then they're saying how many of the electrons in a molecule of ethane are not involved in bonding. So how many electrons in a molecule of ethane are not involved in bonding, all right. So actually initially my answer is this one, all right, this is my answer. But again I'm trying to think, they want electrons that are not involved in bonding, maybe just electrons. Are there electrons in this molecule? Yes. Are there electrons that are not involved in bonding? Yes. So how can we know? So we can know, for instance, carbon, if you go on the periodic table, you find that carbon, oh sorry, let me get that, this one here, and let me rub everything here and start afresh so that you get the concept very well. All right, so when you go on the periodic table, you find that carbon is like this, 6, and then here it is 12. All right, so meaning it has 6 electrons. So the number of electrons in carbon, there will be 6. So in its first shell it should have what? 2. First shell, let's use the crosses, 2, then yeah, 2 here, then then from 6, when you remove 2 you remain with 4, so 4 will go in the other shell like this. So we have 1, 2, 3, 4. Then also, yeah, that's how it is going to be. Then when you look also for hydrogen, because we have seen in ethane there's also hydrogen. So hydrogen, when you go on the periodic table, it is like 1, 1. It means it has 1 electron, so you draw it like this. So according to the rule of electronic configuration, the first shell is supposed to have 2 to be stable. The second shell is supposed to be 8, to have 8 electrons to be stable. But when you look at carbon, it has 4, so this shell is not stable. And then when you look at hydrogen, it has only 1, so this shell is not stable. So now they have to bond covalently. So when they bond covalently, now let me show you how they bond covalently. So this is how they bond covalently. So what happens is, because in this molecule where we have been given like this one here, now I'm going to do like this so that I help you to do it just from here. So here it will mean that carbon will have 2 electrons in the shell, in the first shell, 2, then in the last shell it will have 4. Now if it is surrounded by these 4 bonds, 1 bond, 2 bond, 3 bond, 4 bond, it means it scattered its electrons like this. One was here, another one, oh let me put crosses, one was here, another one here, another one here, another one here. Then this is this carbon, then another carbon is this one. So meaning there was covalent bonding here. So another carbon brought its electrons 2 inside here, again inside there, then like that. So this one also have 4 bonds, 1, 2, 3, 4. So it means it scattered its electron like one here, another one here, another one here, another one here. So now you see that there is also hydrogen. Hydrogen also came here with its own single electrons. It brought it here, so it brought its electron here. Another one came here like here, it's brought its electron here. Another one came here, brought its electron here. Another one came here, brought its electron there. Oh, here there's nothing, guys. Yeah. So another one came here, brought its electron here. Another one came here, brought its electron here. So now these electrons which they bring, we don't show them, we use what we call structure. So we just put carbon where there's a sharing of bond, we just put a line, meaning that 2 electrons being shared. Then here this one brought 1 and this one 1, so we just put a bond like that. Even here this one brought 1 and this one brought 1, so you just put it like that. This one brought 1 and this one 1, also you put a line like that. This one 1, this one 1, also you put a line like that. And this one 1, this one 1, you put also a line like that. And this one 1, this one 1, also you put a line like that. Now, how many electrons are not shared here? When you check here inside the carbon, there are 1, 2, even here 1, 2, they are not shared. So therefore, that's why I had to rethink. This question is tricky. So the ones that are not bonded are these. So this one becomes like our answer. Then I considered it earlier on as this one. So yeah. Now let's move to another question. This question I had to solve it in a different way. I said even these people, they had to put a question mark here. It's not me. I just downloaded it with a question mark like that. So They said A6, the diagram shows an apparatus used to measure the percentage composition of gases in the atmosphere. Phosphorus reacts with oxygen in the air to form phosphorus 4 oxide, which dissolves in water. The initial volume of gas in the tube is 80 cubic centimeters. Then they say what volume of gas remained after all the phosphorus had burned. So after all the phosphorus had burned. So now they wanted to know how much air had remained. So on my part, I thought this question wasn't well phrased because yeah, we know that if inside here there's oxygen and phosphorus is burning, it is using up oxygen. But we don't know how much oxygen was used, whether all the oxygen got finished or did not get finished before this thing formed the phosphorus 4 oxide and it dropped inside here to dissolve. We don't know. So that's the problem of this one. But using my own understanding, I thought if, let's say, oxygen got finished, and we know the percentage of oxygen in air is, let's say it is 20% or 21. So we say, okay, 20% over 100 of 80. The total air you have is 80. Then I said, if you do like this one, and like this one, and like this one, 2 times 8, you get 16. All right. Then you say now, this is the air of oxygen here. So this is the amount of oxygen in here. So out of 80, the amount of oxygen which is in 80 is only 16 cubic centimeters. So now if this is 16 cubic centimeters, then what we are going to do to find what has, since the oxygen now is going to react with phosphorus, if it is going to finish, what I said was then the best, if it will react and gets finished, then what we are going to do is to say 8 minus 20, I mean minus 16, and see what remained. And we saw that it is 64 is the one which remained, and I said in my own assumption I think it is D. I don't know you guys what you think. If you have ever asked someone else and has tried to answer this question, let me know. You can tell me in the comment section, or you can actually chat me on WhatsApp. Alright, so let's go to the other question. Question A7 says determine the relative molecular mass of lead 4 chloride. So this is lead 4 chloride, guys. They want you to determine the relative molecular mass. As I said, relative molecular mass is the sum of the relative atomic masses of the elements in the compound. So this one is a compound, so the relative molecular mass will be adding the relative atomic mass of lead, the relative atomic mass of chlorine. And I said for you to be able to answer this question, you must do like this. You go to the periodic table. Where is the periodic table? Let me get the periodic table, guys. Let me get the periodic table. I opened it recently, so here it is. Okay, so here is the periodic table. So this is the periodic table, guys. So now lead, when you check on the periodic table, you get the relative atomic mass for lead. So lead is somewhere here. The relative atomic mass for lead is this one, 207. So this is the relative atomic mass. This number at the bottom is in mass, atomic number, or proton number. It is also equal to the number of electrons in a neutral atom. So you get 207 for lead. Then you go and look also for chlorine. When you come to chlorine, it is here 35.5 as the relative atomic mass for chlorine. Now you know this, then you come. So for chlorine, since they are saying Cl4, it means these atoms, there are 4 here. So you say 4 times 35.5, which will give you 142. Then for lead, we have found that it is just 207. All right. So 207, I didn't even change here. When I was revising here, it's supposed to be 207. Then after you add this and this. So you say now that the relative formula mass is equal to 142 plus 207. So here 207. When you add this one, you are going to get 349. Right, so 349. So let's just add it so that you can see for yourself. So you say 142 plus 207 equals 349. So your answer is going to be, instead of this one, it is this one. This one wrong.